Universal law of gravitation. In 1687, an English mathematician and physicist, Sir Isaac Newton, put forward this law to explain the observed motions of planets and their moons. According to universal law of gravitation, every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of the masses of the particles and inversely proportional to the square of the distance between them. Let us consider two particles, m1 and m2, are separated by distance, r. If F be the gravitational force of attraction between them, then F proportional to m1 m2 by r square, or F equals to capital G m1 m2 by r square, where capital G is the universal gravitational constant. Value of capital G is 6.67 multiplied by 10 to the power minus 11 meter cubed per kilogram per second square. Acceleration due to gravity of the Earth. Above the surface of the Earth, let us consider a point mass m at a height h above the surface of the Earth. Assume the radius of Earth be capital R and the mass of Earth be capital M. Now, as we know that the mass of Earth is concentrated at its center, the magnitude of force on the point mass m will be F equals to capital G capital M m by capital R plus h square. The acceleration experienced by that point mass will be G dash equals to F by m equals to capital G capital M by capital R plus h square. From the above equation, it is clear that as we move above the surface of Earth, the value of G reduces. Below the surface of the Earth, let us consider a point mass m at which is present a depth d below the surface of the Earth. Consider the radius of Earth as capital R and mass capital M. Therefore, the gravitational force on point mass m will be due to the smaller sphere of radius, capital R minus d, whose mass, capital M dash, is concentrated at the center. Now, capital M dash equals to 4/3 pi capital R minus d cube rho. Here, rho is the density of the Earth. Again, mass of Earth can also be represented as capital M equals to 4/3 pi capital R cube rho. Therefore, capital M dash by capital M equals to capital R minus d by R whole cube, or capital M dash equals to capital M capital R minus d by R whole cube. By universal law of gravitation, the magnitude of force on the point mass m will be F equals to capital G capital M, M capital R minus d by capital R cube. The acceleration experienced by that point mass will be G double dash equals to F by M equals to capital G capital M capital R minus d by capital R cube. Thus, as we go down below the Earth's surface, the acceleration due to gravity decreases. Gravitational potential energy. The potential energy of a system corresponding to a conservative force has been defined as U equals to minus integration F dr. Let two particles of mass m1 and m2 are situated r distance apart. Then the gravitational force on the particle of mass m2 by m1 is F equals to capital G m1 m2 by r square. If m2 is moved by a small displacement dr, then the work done by the gravitational force is dw equals to minus capital G m1 m2 by r square dr. Thus, work done for moving from infinity to r, w equals to minus integration from r to infinity, capital G m1 m2 by r square dr. Therefore, potential energy U equals to W equals to minus capital G m1 m2 by r.